Hey guys, hope you're well. So in the previous lesson, we started looking at displacement time graphs. In this lesson, we will be focusing on velocity time graphs. Now, we're going to take a little bit of time trying to understand what the graphs represent. Remember that this is not a displacement time graph. This is now a velocity time graph. So it has its own understanding, and it's a totally different kind of graph. Okay, so let's have a look. If we, for example, look at this position over here. Okay, over there. Wait, why is it doing that? There. That position over there is probably 1 second, somewhere around 1 second. And if you look at the velocity, it's 1. Now, the velocity is positive 1. So it says that east is positive. So that means that at this position over here, the person, let's just say here, person is walking at 1 meter per second. Remember, meters per second is almost like a speed. Velocity is almost, you can think of it as almost the same as speed. Yes, they are a little bit different, as we've learned already, but you can think about it as how fast is the person walking. So the person is walking at 1 meter per second over there, and they're going in an easterly direction. Why? Because the velocity is positive and east is positive. Okay, now if you, for example, look at this position over here, let's say the time is, I don't know, 4 seconds maybe. And if you look at the velocity of that person is 3. So it means that along this line, the person is walking faster and faster and faster. So we can say that the person is accelerating. Because when an object is getting faster and faster and faster, and it's not just moving at the same constant speed or velocity, but it's getting, the velocity is changing, then it's accelerating. So here we, at this position over here, we could say that actually let's make this a lot neater. I'm not making this really neat. Let's say that this is position, this will be position A. Let's say this is position B, and let's say position C, and let's say E. Let's go for there, up till there for now. So A, B, C, D, and E. So what we said at A was that they are moving. Let's not say walking. Oh, no, they are saying they're walking. Okay, so walking at 1 meter per second east. Okay, now at point B, we said that the velocity is 3, so they're still walking east at 3 meters per second. So they're still walking east. So they have not changed direction. Okay, now at point C, they are now walking at 4 meters per second. So walking at 4 meters per second east. Now, here's where learners start getting confused. They think that when it goes down like this, the person is turning around. That is not true. That is only true when you are looking at a displacement graph. On a displacement graph, then when you start coming down like this, then it means the person is coming back to the starting position, which we used to label like this. But that only works on a displacement graph. Check this out. If you were to look at point E, let's actually put point E over there. Now, if you had to read off the E value's velocity, look at that. It's still, the person is still walking. Now they're walking at 2 meters per second, but they're still going east. They have not turned around. If they turned around, they would be going west. They are still going east. Okay? So the velocity is, all that's happened, guys, is here on this part, the person was getting faster and faster and faster, and now they have not turned around. They're just slowing down a little bit, but they're still going east. Okay, now if you look at this point over here, which we'll call F, we can read off the velocity is 0. So all that the person has done there, oh, sorry, that was meant to say D. I see where there's a confusion. That was meant to say D, and now, oh, I see, okay, there we go, and now E. Okay, oh no, F, let's call it E over there. My goodness, sorry guys. So E, the person has stopped. Person is, let's say they're standing still. Person is standing still, okay? But they have not turned around. They didn't turn around for any of this, okay? They walked in one direction. They were always going east, and now they've just stopped, and they're just chilling for a bit. Okay, now if for example we look at point F, now if you look at point F, the velocity is -3. Okay, so what that means is that the person is walking at 3 meters per second, but now they are walking because the velocity is negative, they're going west. Because if east is positive, west is negative. Okay, now if you look at point G, and then we're also going to look at point H. So at point G, the person is now walking at -4. What are you writing there? Person is walking 4 meters per second. So the thing I'm trying to make you understand is that this is a totally different graph to displacement, and you must not think of them as the same thing. It's totally different. Okay, so the person is walking 4 meters per second. What did we say? West. Okay, now on a displacement graph that we looked at in the previous lesson, when this line became flat, then we would say that the person is not moving. But that is not the same on a velocity graph. How is it not the same? Well, look at point H. If you look at point H, what is the velocity? The velocity is still, the person is still walking at 4 meters per second. So the person they can't be standing still, they're walking 4 meters per second, and they're still going west. So can you see that when the graph is going like this, the person is getting faster and faster and faster? So in that yellow part, we can say person is walking faster. We can say they're accelerating. That's a better word. We can say person is accelerating because they're getting faster and faster. Now, over this area over here, the person was slowing down. Remember, we said that the velocity was getting less because at you understand what I mean, right? We spoke about that. For example, over here, the velocity is 3, but then over here, the velocity is 1. So the person is getting slower. So for that green part, we can say person. Now they're slowing down, so I'm going to use the word decelerating. Remember, I spoke about in one of our previous lessons about positive acceleration, negative acceleration, and how a lot of teachers get that part wrong. Okay, if someone's speeding up, they're getting faster. We accelerate, getting faster. And then if someone is getting slower, you can call that deceleration, so getting slower. Or let's say slowing down. Now, in this area over here, some learners say that the person is getting slower. But that's not true. If you look at the numbers, don't worry about the negatives, just look at the numbers. It's going from 1, so for example, there the velocity is 1, but then there the velocity is 2, there the velocity is 3, and there the velocity is 4. So for that part there, the person is actually accelerating. The negative's just telling us that they're going in a westerly direction. That's all that means. So they're not getting slower there. So for that blue part, we will say that the person is accelerating. And what I could have even said over here was east. Over here I could have said east. For this one, let's rather write it over there. And then for this one, the person is now going in a west direction. And then this last little piece, we can say person is moving at constant velocity. So person moving at constant. Oh, and for the rest of this lesson, by the way, we're still going to do calculations. You see, we're going to do calculations. I'm even going to be showing you like how to calculate the area under the graph. Maybe your teacher showed you something like that. We're also going to be calculating, all sorts of stuff. And we got quite a lot of examples coming up. Okay, so stick around. We're just getting into the introduction still. So person moving at a constant velocity. So when you're moving at a constant velocity, we can say that the acceleration is 0. Acceleration is equal to 0, and we are moving in a westerly direction. Why do I say west? Well, if you look at the velocity is -4. So we know that east is positive, so then west is negative. Okay, now let's go and actually analyze this question, or let's go look at the questions and do some calculations. Now we're going to start looking at all the questions, and there's some really interesting things we're going to learn. We're going to start looking at the area under the graph, and we're going to learn what that means. So yeah, the first question says, determine the acceleration. Okay, so we've learned that acceleration is equal to the change in velocity over change in time. And when we expand that formula, it's the final velocity minus the initial velocity over the final time minus the initial time. Now, when they say final and initial, I don't want you to just think start and finish. No, it depends on where they are talking about. So they say determine the acceleration in the first 5 seconds. Okay, so that would be from here up to here, so up to 5 seconds. So it's this part on the graph, because that's 5 seconds, and this part. So this part over here would be the final, and this part would be your initial. Remember, final means the last part, and the initial means the start part of where they are talking about, okay? And then this would obviously go with the final time, and then this would go with the initial time. So if we then go use our formula, the final velocity is 4, then the formula says there's a minus, and then what's the initial velocity? 0. What's the final time? 5 seconds. And what's the initial time? 0 seconds. If you work this out, you get 0,8. Now the units of acceleration is m.s minus 2, and now have a look at this. East is positive. We got a positive answer, so the answer is east. So we can just say here 0.8 meters per second to the negative 2 east. Now things are going to start getting interesting. It says here, what is the total displacement for the 15 seconds? Now, I want you to write this down somewhere, or you need to memorize this. But displacement, or whenever they talk about displacement, or when they talk about distance on these types of velocity time graphs, I want you to think of area, okay? I want you to think of area. So the way that it will work is the following. Now, I'm going to do a lot of examples with you in this lesson, so just bear with me. It might be a bit weird for this first calculation that we do, okay? But just trust me, it's going to get easier. So have a look here. It says, what is the total displacement? So I want you to think of area for the 15 seconds. So what you do is you're literally just going to go look at the area under the graph. So you're going to go calculate this entire area over here. Okay, so you're going to calculate that area. Oh, and I forgot to mention before we started this question, this time of year, we're going to assume that that's 7.5. In a test, they'll make that a lot clearer. And then, okay, so you're going to find that area over there, and then you're going to have to go find this area over here, up to there. So it's the area between the x-axis and the curve. Can you see that? So here's the x-axis, okay, and so that's the x-axis, and then the curve. So let me show you once again. So you see you've got the x-axis, and then you're just going to fill in the space, all of that, and then here you've got the x-axis, and then you're just going to fill in the space up to the 15 seconds, which is where we stop. Okay, now what you are going to go and do is for the displacement. Or let me first show you something. Sorry, sometimes while I'm thinking about the best way to explain it, I think of a new way to do it. So what we're going to do is we're going to go work out the areas, okay? So we're going to go work out the area of the shape over here, and then we're going to go work out the area of the shape over here. Now this shape is a triangle. Now, to work out the shape of the area of a triangle, you could do this in two different ways. You could either draw a perpendicular height over there, and then you could work out the area of this one, and then you could work out the area of that one, and then just add them together. But there's a better way. Did you know that the area of a triangle is half base times perpendicular height? We have, if you look at the base, it's this entire piece over here. That would be 7.5. That's how long that would be, 7.5. And the perpendicular height, we actually know the perpendicular height. It is from the top here to the bottom. And that height would be 4. Okay? So you could just go work out the area of this triangle in one step. But if you're not comfortable with that, as I said, you could work out the area of this side and this one, and then just add the two answers together. So for that one, you're going to get half base. Now the base is 7.5 and the height is 4. Okay, so that's the first part. Let's call that section A. So we've done section A, and if we calculate that, we get 15. Okay, now that's just going to be 15 meters. I know that area is meters squared, but what I told you is that area, to find the displacement, we just need to find the area under the graph, and displacement is measured in meters. Okay, now we're going to go find the area of this piece. Now you could get fancy if you wanted to, and you could be like, oh yeah, bro, this is a trapezium. But for the most students, I think we'll all just be more comfortable. Let's break it up into a triangle. Let's break it up into a triangle, which I'll call section B, and then we can do this rectangular kind of shape, which we'll call C. So for B, it's a triangle. So half base times height. So the base would be from here to here. So what is 7.5 up to 10? Well, that's 2.5, right? So this length is 2.5. So we say 2.5. Now, here's where you got to be. Quite careful. So look at the height. It goes from 0 to -4. So that height, I want us to put that height as -4. Okay, because yeah, you'll see why we do that now. So you're just going to put that as -4. And if you had to go calculate that, you get -5 meters. Okay. And then we're going to go work out the area of section C. And so that's going to be a rectangle, which is just length multiplied by breadth. So that's going to be the length is 5. And then the height, or the whatever you want to call it, is going to be -4. And so that's going to give us -20. Now, here's the important part. Okay. When you are calculating distance, which we are going to do in question C, you just add the numbers together, but without the negatives. So you just say 15 plus 5 plus 20. You don't look at the direction or the sign. You're just looking at the actual value. And so if you had to go add that up, you're going to get 40 meters. Okay, that's for distance, 40 meters. When you are doing displacement, remember that displacement is a vector, so it has direction as well. So all of these positive numbers are east, because east is positive, and all of the negative ones, all of the negative ones are going to be considered west. Because we said in the previous slide that at this part over here, the vehicle was moving west. Okay, so it makes sense that the displacement is negative. And so for displacement, you are going to take all of these signs into account. So you're going to say 15 minus 5. Well, you could plus them. You could technically say plus, and then that one's -5, and then plus -20. And if you had to go work this out, you would end up getting -10. So what that means is that the final displacement is going to be 10 meters west, because east is positive, west would then be negative. So for distance, you just add all the numbers together. For displacement, you take the sign into account. Okay, so let's go do a whole bunch more practice now. Let me just quickly fill this in. 10 meters west. Notice that I have to give the direction, because why? Displacement is a vector. For distance, you don't, because it's just a scalar. Let's go practice this some more. I know it might be feeling a bit weird still. Okay, let's have a look at this one. I start riding my bicycle from my house. Assume that east is positive. Okay, so if we look at this first section over here, this first section, I'm going to call this section A. Or actually, let's stick to what we did earlier. So we're going to do that. So that first part. If you look at what happens is I start riding my bicycle from resting position at 0, and then I increase my speed all the way to 60 meters per second. Geez, that's actually really fast. That's like, what is that? That's, if we convert that into kilometers per hour, wow, I'm riding my bicycle at 216 kilometers per hour. Maybe it's a motorbike. Okay, so we're going all the way from 0 up to 60 meters per second. So you see how we are accelerating over here. We're getting faster and faster. And because the velocity values are positive, it means we're moving in a easterly direction. Okay, so for that yellow part, we are accelerating and we are moving east. Okay, now for this part over here, some learners will say that we are not moving, but that is because they are confusing this graph which is a velocity graph, they're confusing that with a displacement graph, which we've looked at in previous lessons. You're not standing still over here. You're moving. Look at this. Your velocity is 60. So you are moving. You're just moving at a constant velocity. You're not increasing or decreasing your velocity. It's staying the same. So this part, which I'm going to put over here, is going to be moving at a constant velocity. Moving at constant velocity. And because the velocity is positive, we're still moving east. Okay? And then we'll say that there is no acceleration, or we'll say that the acceleration is 0. There's only acceleration or deceleration when your speed is, or your velocity is going up or down. But when your velocity is staying the same, you're just cruising along at 60 kilometers or 60 meters per second. Okay? Now for this part here, some learners will say that we are turning around, but that is because they are thinking of a displacement graph. If it was a displacement graph, then you have turned around. But on a velocity graph, think about this carefully. If you look at the velocity over here, the velocity is 40 and it's positive, so you're still going east. You look at the velocity here, it's 20 and it's positive, so you're still going east. So all that happens from here to here is the person maybe started using their brakes and they're just slowing down, but they're still moving east. They're still moving away from the starting position, okay? But if it was a displacement graph, then this would mean the person has turned around. But this is not a displacement graph, this is a velocity graph. So all that's happening is the person is just slowing down. Think about yourself riding a bicycle. If you start pulling your brakes, you're still going to go in the same direction, but you're just slowing down. So for that part, we could say we are decelerating now because our speed is slowing down. Well, velocity, we're decelerating, but we're still moving east. We are still moving east. Now, at this point over here, if you look at your velocity, whoa, Kev, you can't highlight a red 0 with a red highlighter. If you look at this part here, our velocity is 0. So that means the person is standing still. So person is not moving. Okay, now if you look at this part here, now some people would say that the person is slowing down because as soon as they see this, they see slowing down. Now this part was slowing down. You see, this is where you got to understand these things so carefully. So here we were slowing down because look at this. Your velocity went from 60 to 40 to 20. So you are slowing down. But if you look at this blue part, you're actually speeding up because look at your velocity over here. It's 20. And then look at your velocity over here. It's 40. The negative just means that you're going in the opposite direction, but you're actually speeding up. So even though this line and this line looks the same, when it was here, you were slowing down, and when it was here, you're speeding up. You just have to look at the value on the y-axis. Over here, you're going 20, and over here, you're going 40, so you're speeding up. The negative, as I said, just means that you're going in a westerly direction. That's all. So when the person got to here, they stopped, turned around, and now they are going in a westerly direction. Okay, so we can say here that they are accelerating and they are moving west because the velocity values are negative. Okay, now for this last piece, you might be tempted to say, oh, the person's speeding up because when we had a graph look like that earlier, that means speeding up. But it's not true. You have to look at based on where we are on the graph. So if you look at this, the velocity over here, over this part, the velocity was 40. I'm not going to worry about the negative. That just means the direction. So the 40, okay? Then if you look at the velocity over here, if you read it off there, it's like negative 10 or just positive, you can think of it just 10. So the person from here to here is slowing down. And when they get to this position, the velocity is 0. So here they have stopped again. So from here to here, the person is using their brakes and they're slowing down. So we can say that we are decelerating because we're slowing down. And we're moving west. Why are we moving west? Well, if you look at all the velocity values, they're negative, and east is positive, so west is negative. So decelerating and moving west. So it's really important that you understand exactly how we got each of these things, okay? Now we're going to go do some questions on this. So the first question says, determine the acceleration in the first 10 seconds. So we know that acceleration is equal to change in velocity over change in time, which is then final velocity minus initial velocity over final time minus initial time. So they're only asking for the first 10 seconds. They're not asking for all of it. So the first 10 seconds is up to there. So that means over here and over here. So this would be your final velocity as well as your final time. And then this would be your initial velocity and your initial time. And so if we had to go fill this all in, your final velocity is 60 minus your initial velocity is 0. Your final time is 10 seconds and your initial time is 0. So if you had to go work this out, you get 6. And then that's meters per second to the negative 2. And then because it's a positive answer, east is positive, so we must say east. So we're going to say 6 meters per second east. Or 6 meters per second to the negative 2. Okay, that's important. Next question, B, says determine the total distance traveled. So remember what I've told you in the previous slides is that when you have a velocity graph, only when you have a velocity graph, then distance, whenever they say distance or displacement, I want you to think about area under the graph. Now, when we talk about area under the graph, I just want you to look at the x-axis, which is this one, and then you're just going to fill in the gap. So there and there. Okay, now let's go work out the area of those sections. So this part here, you could be fancy and do a trapezium, but I think what most learners would like to do is a rectangle. Whoa, Kev, that's not a rectangle, it's a triangle, my dude. So a triangle over here, which I'll call A, then a little rectangle over there, which I'll call B, and then a triangle over here, which I will call C, and then this is one big triangle. So we could just do that as one big triangle. If you wanted to, you could do 2 smaller triangles, but it is just one triangle, so we're just going to go D. Okay, so for section A, it's a triangle, so we're going to go half base times height. So the base length would be from here to here, which is 10 seconds. And then the height is, see now the height of the triangle is going to be that part, and so that's going to be 60. So we're going to put 60 over there. If we had to go work this out, we end up with 300. Now remember, we're working out distance and displacement, so that's meters. For section B, that's a rectangle. So for that you need with a rectangle, you multiply this side with that side. And so we're going to take, for example, this length, which is 5, because it goes from 10 over here, and then this one in the middle would be 15. So that's 10 to 15, that's only 5. So we're going to say 5. We don't say half. Half is only when it's a triangle. And then the height is going to be 60. Okay, so we're going to say 5 times 60, and so that's going to be 300 meters. Now we're going to do section C, which is a triangle again, so that's half base times height. So the base length would be this part over here, so that goes all the way from 15, which is this part, from 15 up to 30. So that's going to have a length of 15, because 15 to 30 is 15, and then the height of that triangle is all the way up to there, so that's going to be 60 again. So 60. And so this gives us 450 meters. All right, so now we just need to do this part. And so this one is also a triangle, so it's going to be half base times height. Now the base goes from here up to here, and so that is from 30 all the way to 55. So what is 30 up to 55? That's 25. Okay, now for the height of that triangle is from here to here. See, it's that height over there. So you got to look on the y-axis over here, and you can see that it's going from 0 up to negative 40. So that height is negative 40. So we include the negative Okay, and if you had to work this out, you're going to end up with, you get negative 500 meters. Okay, so now when we calculate distance, we just add the numbers together and we don't worry about the negatives. So for question B, when you calculate the distance, you're just going to go 300 plus 300 plus 450. So we'll just say plus 500 over here. And if you had to go calculate all of this, you end up with 1,550 meters. Now, when you look at displacement, you do take the sign into account. So you're going to say, so for question C, you're going to say 300 plus 300 plus 450 plus, and then this is negative 500. And so if you had to go calculate that, you get 550 meters. But now you're getting a positive answer, and east is positive, so we say east. Remember, displacement is a vector, so it needs direction. So we're going to say 550 meters east. I'm just going to put an E there for east, okay? This one says, determine the acceleration. Okay, so we know acceleration is change in velocity over change in time, which is then final velocity minus initial velocity over final time minus initial time. But they're asking us to only look between 40 and 55 seconds. So 40 and 55 seconds, that's from here, and then 55 seconds is here. Okay, so these are the two positions that they're asking us. Now, which one is later, or which one is the final one? This is your final one because it comes at 55 seconds. So this is the one to the right is your final. So this is your final, and this will be your final time. And then this will be your initial and your initial time. Kevin, I thought this is the initial velocity. No, it depends on where they are talking about. So if the question is talking about this part, then this is your final, this is your initial. If they were talking about from here to here, then this is your final, this is your initial. Okay, so let's go fill in our formula now. So the final velocity is 0, if you read off the velocity there. Your initial velocity is over here, but remember that you mustn't look at that 40, that's the time. You got to look on the velocity axis, and so that's negative 40. You see there, it's in line with that, so it's negative 40. So you're going to put negative 40 here. So you see you have two negatives next to each other there. And then for your time, your final time is this one, which is 55 seconds. And then your initial time is this one, which is 40 seconds minus 40. And so if you had to go calculate that, you end up with 2.67, and that's meters per second to the negative 2, because that's what acceleration is measured in. Now, we just got a positive answer. So because east is positive, we're going to say east. But Kevin, how can the acceleration be positive if the velocities are negative? Guys, acceleration and velocities are slightly different things. These are the velocity values. So the velocities are negative here, but it doesn't mean your acceleration is going to be negative. So that's going to be the end of this lesson. But if you still want to practice some more of these, then I'm going to add another video. So just look for the video immediately after this one, where we can, or where you can do some more practice questions. Okay.